Hello, boys and girls. Welcome to Eureka Math, Module 2, Lesson 1. This is Miss Moreno. Let's look at today's topic, interpreting division of fractions by a whole number using visual models. And let's break that up into your learning targets. I will use visual models, such as fraction bars, number lines, and area models, to show the quotient of whole numbers and fractions. And I will show the connection between those models and the multiplication of fractions. So here we have the opening exercise. I'm going to go ahead and just focus on part A since we're not in the classroom. So this is more for you to review how you set up division problems. So let's look at number 1. 8 gallons of batter are poured equally into 4 bowls. How many gallons of batter are in each bowl? So we're looking at 8 gallons of batter, and that's poured into 4 bowls. And the word equally and each are the key words that tell me that we will be dividing. So when I set this up, I am dividing 8 by 4. Now, every single problem in this lesson will be division, right? If we look at our learning targets, we're looking at division. But it's always great to recognize the keywords that tell you if you're doing addition, subtraction, multiplication, or division. Number 2, 1 gallon of batter is poured equally into 4 bowls. How many gallons of batter are in each bowl? So I'm looking at 1 gallon, and that's poured into 4 bowls. And the word equally and each tell me it's division. So I would set this up as 1 divided by 4. Now, I'm going to go ahead and skip number 3 and get right to the lesson because it's very similar. So let's start with example 1. We have 3/4 gallon of batter is poured equally into 2 bowls. How many gallons of batter are in each bowl? So let's look at the information that it's giving us. I have 3/4 gallon of batter, and that is poured equally into 2 bowls. The word equally tells me I'm dividing. And I need to answer how many gallons of batter are in each bowl. So, on our learning target, we said we were going to divide using visuals. So, let's go ahead and draw a visual that shows 3/4. So, to do that, I start with 1 whole, and I divide that whole into 4ths. And I'm going to shade in 1, 2, 3 out of 4 to show 3/4. So we're dividing 3/4 by 2 because we have 2 bowls. So I'm going to go ahead and divide this by 2 right here. Just divided it by 2. Now we have 2 bowls, right? We have 1 bowl, 2 bowls. I want to know how much is in each bowl. So I want to know what is in 1 bowl. So this is 1/2. Because it's 1 bowl out of 2. So I want to know how much is in this bowl right here. So if I count, I shaded in 3 units out of 8. So my answer is 3/8. So now I have enough information to answer how many gallons of batter are in each bowl. There are 3/8 gallon of batter in each bowl. Now, I know this was fast. You can rewind this as much as you need. I'm still going to go over it with you live in the live stream. I will also record the live stream. I will show you different ways to do this, but we do need to do this with a model. It's understanding how we got 3/8. And again, we're still going to do more examples. So let's look at the next example. Example 2. 3/4 pan of lasagna is shared equally by 6 friends. What fraction of the pan will each friend get? So let's start by annotating, right? We're looking at 3/4 pan and 6 friends. And the word equally tells me I will be dividing. And I want to know what fraction of the pan will each friend get. So what we're doing here, just like in the opening exercise, first I set up my division problem. I have 3/4 and I want to divide that by 6. So I'm going to start by drawing that 3/4. To draw 3/4, I start with one hole. I partition my hole into 4 equal parts. And I need to show 3/4, so I'm going to shade in 1, 2/4, 3/4. I just shaded in 3 out of 4, so that gives me 3/4. Okay, so let me back up one step. Now I need to divide the 3/4 by 6. So I'm going to go ahead and partition this fraction into 6 equal parts. Now I can move on. I just split this up into 6, cut it up into 6. I want to know what fraction of the pan will each friend get. So this is what one friend will get, right? 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, right? Each section that I circled equals 1 6 because that's what each friend will get. There are 6 friends, but each friend will receive 1 out of 6. So I'm just going to label that as 1 6 to show that's what one of the 6 friends get. Now I have enough information to answer what fraction of the pan will each friend get. Well, I can see right here. Let me double shade that for you. This is what one friend gets. That friend gets 3 out of 24 because she gets 3 because there are 3 shaded, 3 units shaded, but there's a total of 24, so 3 out of 24. So now I have enough information to say that 3/4 divided by 6 equals 3/24. Now I'm going to go ahead and say each friend will receive 3/24 of the pan. And if you notice, you can also simplify 3/4 to 1/8. So that means that each friend will receive 1/8 of the pan. And don't worry if you don't remember simplifying, we'll cover that in another lesson. So for example 3, I would like for you to pause it, try it on your own. It's okay if you make mistakes, that's how we learn. Go ahead and pause it, try it, and then play it. And I will also again go over it in the live stream. A rope of length 2/5 meter is cut into 4 equal cords. What is the length of each cord? Now, our learning target says that we're using number lines, area models, fraction bars. I'm going to continue using the same model I was using, but in the live stream, I'll add different models just so I'm consistent with the video. And I did tell you to try it on your own so that you can see the same pattern that you have been following. So I'm going to start by annotating. Always annotate, boys and girls. It really helps when you're doing the work. So I have 2/5 meters, and I want to cut that into 4 equal cords. And again, the word, I'm cutting into 4 equal cords. The word equal, I know I'm dividing. And I want to know the length of each cord. So I'm going to start with one hole. And I'm going to partition the one hole into 5 equal parts. Next, I'm going to shade in. So I need to remember to set up my problem, right? So we're doing 2/5 divided by 4. So now I can shade in my 2/5, and let me go ahead and label that really quick. 2/5. And now that I label my 2/5, I need to divide into 4 equal parts. And remember, I want to know what the length of each cord is. So that's 1 cord, 2 cords, and again, I shouldn't say that it's one out of 4, right? Because it's 4 cords. That's 2/4, 3/4, 4/4, and if we look at them individually, it's 1/4. Because again, if you have 4, we cut into 4 parts. I only want to look at one of them because I want to know the length of each one. So this is 1/4. Now, what is the length of it? So I can clearly see that I shaded in 2 units, and there is a total of 20 units. So the length of one chord is 2 out of 20, 2/20 meters. And 20 can be reduced to 1/10. So the length of each chord is 1/10 meter. Now, I know a lot of you are used to seeing the division like this, right? 2/5 divided by 4. And maybe in the past your teacher told you to solve this, you leave the first number the same, you change your division to multiplication, and you write the reciprocal of the second number. So if we have 4, it's the same as 4/1, so the reciprocal would be 1/4. And if I multiply across, you get 2/20, and again, we know that reduces to 1/10. Now you might be asking, well, why couldn't I do that in the first place? It's way easier. You know what? I use this every time just to check my work. But the point is for you to understand how we got that 1/10. Not just, let me flip the second number, right? And not flip, right, the reciprocal of the second number. Why we're doing that. So think about it. Just, something to think about. If we have 2/5 and we divide it by 4, when we get our answer, we're looking at 1 of those fourths, right? We have 4, we divided it by 4, but we're specifically focusing on 1/4. So if I had 2/5 and I multiply by 1/4, I get 2 out of 20, which reduces to 1/10. And we're going to look at that in more detail in the next portion, in the next exercise. So here it says, fill in the blanks to complete the equation. Then find the quotient and draw a model to support your solution. So I have 1/2 divided by 3. And I don't know if yours has this mistake, and I know mine does. Right here, let me use my highlighter. That should be a 3. So I'm just going to go ahead and fix that really quick. Okay. So if yours is a 2, that's supposed to be a 3. Okay, so now let's look at this. Fill in the blanks to complete the equation. Then find the quotient and draw a model. Okay, so before I even fill that out, I'm going to start by drawing my model. I have one whole. I'm going to divide that into 2 equal parts and shade in 1/2, which is 1 out of 2. Now I'm going to divide this into 3 parts. And again, this is 1/3, right? 2/3, 3/3. And when I look at them individually, it's 1/3. Now, I'm shading in what 1/3 looks like. I just shaded in 1 out of 1, 2, 3, 4, 5, 6. 1 out of 6. So this represents 1/6. So 1/2 divided by 3 equals 1/6. Now, let's think of what you have been doing in the past. You have 1/2. Your teacher would normally say, write the reciprocal of 3. Change your division to multiplication, then write the reciprocal of 3, which would be 1/3. And that gives you the answer, which is true, but it's understanding why. So I just showed you, if you have 1/2 and you divide by 3, we want to know what one of those parts is, and that's 1 out of 3. That's so we can multiply 1/2 by 1/3 to get 1/6. That's how this works. And again, we needed to do this using a model, but I do go back to and solving it this way just to check my work. And Now I have enough information to fill out the missing blank. So I know that I multiplied, what did I multiply by 1/2 to get the answer? We multiplied 1/3. So 1/3 times 1/2 gave us 1/6. So I'm going to go ahead and stop there. I want you to try exercise 2 and 3 on your own and come ready to go over exercise 2 and 3 in the live stream.